Okay, students, today we are going to see that how sound, speed of the sound, speed of the sound in different medium. Okay, so this thing we are going to see today. See, one thing you have to know. See, already we know that what is that speed. So generally we know that what is that speed. So speed of the sound. Okay, so just we have to know that speed. So which is equal to distance divided by time. Okay, distance divided by time. So this is that basic thing. So what is that speed? Okay, see, I already said, students, what is mean by sound. See, sound is nothing but it's a kind of vibration of an object. Okay, and even in the last class, okay, even the last class we have seen that what is that basic properties, what are the basic properties based on that sound. Okay, see, for example, here I will split as, okay, uh, frequency. So we have seen about frequency, and what is that pitch. Okay, so we have seen that pitch, and next thing is amplitude. We have seen, right? Am I right? What is mean by amplitude, and next one, how it will be depends on that the sound waves will be characterized of what's called loudness. So these are the some basic properties we have seen. Am I right? In the last class. Okay, so today we will see that how the speed of the sound will be in different medium. So generally in medium we can split as, so what are the mediums here? So I will write some mediums, you just know about it. Solid, okay, so liquid and the gas. Okay, when the sound will be traveled in solid, what happened to the speed? When the sound is traveled in the liquid, what will happen to the speed of the sound? Same way in the case of gas. Okay, see, one thing you have to know, the sound it will depends on that pressure. Okay, sound will be depends on pressure and temperature. Okay, pressure and temperature. For example, I will write here, see, if the temperature I will write, so temperature directly proportional to pressure, sound. Okay, so temperature directly proportional to sound, that means sound is directly proportional to temperature. That means if temperature is increasing, the speed of the sound also increasing. If the temperature of that body will be decreasing, means the sound of that body, respective body, also decreasing. So this thing you have to know, students. Same way in the case of pressure also. When the pressure will be very high, it will produce lot of sound. When the pressure will be very less, it will produce less sound. Okay, students, and one more thing you have to know. See, at, for example, at 0 degrees Celsius, what is the speed of the sound? So at 0 degrees Celsius, the speed of sound will be nearly 330 to 331. Okay, so speed, it should be calculated in terms of meter divided by second, meter per second. That's the SI unit. Okay, so at 0 degrees Celsius, it will be 331 meter per second. So at 22 degrees Celsius, what will happen to that sound? It will come nearly 344 to 345. That range will come. So 344 meter per second, that much speed it will go. Okay, students. So this thing you have to know, this is the major fact. Okay. So what will happen at 0 degrees Celsius? It will become 331. So this, from this, what you have to know, so based on the temperature, the speed of the sound will be varying. Okay, so even and what's called in pressure and all, for example 1 atm, 2 atm. Atm means nothing but atmospheric pressure. So for 1 atmospheric pressure, what will happen, 2 atmospheric pressure, same way likewise that speed of the sound will be varying. Okay, next thing is we are going to see that what is that reflection of sound. Okay, so we are going to see that reflection of sound. Okay, so you already know about what is that law of reflection. Okay, see, you already know about law of reflection. So law of reflection in the light you already studied. Okay, so first I'll write law of reflection. Okay, what is mean by law of reflection? See, for example, if I'll take one plane, so in this is a plane. Okay, see, when you are passing the light at certain angle, what angle you are passing, that angle it will go, right? So that means this is called incident ray, this is called reflected ray. Okay, see, and this is called incident angle. Okay, so I will write here, this is called incident angle and this is called reflected angle. Okay, and from the center there is one perpendicular line, it will go, so that is called normal line. Okay students, so this is called normal line. Okay, so incident ray, see, first I will write about it. So here the angle of incidence must be equal to angle of reflection. Okay, I am explaining about that light concept, so we will come to that sound. Okay, don't worry about it. Here same way here, so the incident ray and reflected ray and the normal line. So the normal line I will write here P and Q. Okay, see, this normal line all are lie in same plane. Okay, all are lie in same plane. Okay sir, why you have to say this one, sir? Because we are studying the sound concept only, no? So why, sir, we have to learn about it? Same way how light is behaving, same way the sound also behaving. Okay, for example, in your book they gave one example. Okay, just I will just pick here. Okay, see, okay student, just a minute. Okay, here, so I will just, I'm using this one. Okay, yes, see, one thing you have to know, students, here in this picture what you can learn. First, here they placed one clock. Okay, so here they placed one clock. When this clock, already the clock is producing some sound, am I right? The clock is producing some sound. So here, okay, so sorry, yes, here, okay, the clock is producing certain sound. The sound is going in this narrow tube, the straight tube. Okay, and once it will be hit in the hot surface, okay, hit in the hot surface, it will be bounced back, it will be reflected back to the receiver ear. Okay, so here it will go this kind of. Now what is the difference? Same way here the light also going this manner only, what angle it is coming, what it will be going at the same angle. Same way here the sound producing device, maybe here they have taken clock, so from this device the sound, the waves and all, it will be going in this straight way, and once it will be hit at that point of incidence, then after it will get reflected. Okay, so it will reflect and we will receive that sound through the organ of ear. Okay students, and this activity they gave in your book. And the next thing is you have to know, so first, okay students, so that activity I give. Okay, so and one more thing, what is that, the next concept is echo. Okay, what is mean by echo? See, one thing you have to know students, so echo is nothing but, for example, here one sound producing device, so any device I have taken, okay, any sound producing device, so from this it will go at certain distance. After that time it will be bounce back, it will come back. Okay, so the same where it will be producing the same, that's called source, right? So at the source point it will come back. So this is called what is called reflected sound wave. Okay, reflected sound wave. Okay, so one is receiving, one is transmitting, so this is called transmitted wave. So when it will be happen, sir, suppose if you are in the mountain or any large building, okay, any tall building or any tall structures is there, so at that time if you are producing certain sound, so it will come back to the receiver 0.1 second. Okay, so this is called echo. So for example, from this device if I produced any sound, after 0.1 second I will receive that echo. Okay, I will receive that reflected sound wave. Why? Because here any what's called tall building or anything is there means, so the sound will be get reflected back, so it will come within 0.1 second, it will come back. Okay, so that you have to know students. So echo is very important. Okay sir, where is that echo and all they are using, sir? Even what is called, if you are going to that any mountain area, for example hill station and all, so that time if you producing any sound means, what will happen, it will come back a lot of time, it will come back, it will receive in various wave, because you are continuously producing sound. Okay, and the next thing is you have to know that, see that echo I said no, so that is called transmitted and the reflected wave. And one more thing I want to share with you. See, reverberation.